Hey everyone, so today we'll be solving a LeetCode medium problem, a number of subarrays with odd sum. So like the problem states that we are given an array of integers and we need to simply return the number of subarrays with an odd sum. And we know like the number of subarrays can go up to n square. So here n can go up to 1e5, so it will be like 1e10, which may go to long values. So hence like we need to return the result such that it is modulo 1e9 plus 7, so that it stays in the range of integers. Okay, so for example, if we have this input, so what will be the possible subarrays? So we'll have 1, then 1 3, then 1 3 5, then we'll have 3 3 5 and 5, and the sums will be 1 4 9 3 8 and 5. And as we can see, odd sums here are 1 9 3 and 5. Hence the output here is 4, because there are 4 subarrays which have odd sum. Okay, let's try to see another input. So as we can see, like here we have 2, the subarrays will be 2 2 4 2 4 6, then 4, then 4 6 and 6. As you can see, since all the values are even, so all the sums here are even only. Hence there will exist no subarray which has an odd sum, hence the output here is 0. So the brute force, what will be the most naive way of doing it will be to simply like iterate through all the subarrays possible and calculate the sum of that subarray and see if that sum is odd or not. Okay, so what will be the brute force way? We just iterate for all the starting points of the subarray from 0 to n minus 1, and for all the ending points of the subarray from I till n minus 1. And we'll see if we have this subarray I to j, we can maintain a running sum equals to 0, we can maintain a running sum, and we'll check if this sum is odd. If this sum is odd, then we'll update our result, means overall count of odd sum subarrays by 1. So this will be like the order of n square approach, and obviously this will give us TLE because n can go up to 1e5 only. So what will the code look like? So we have the value means mod as 1e9 plus 7. We'll initialize the odd subarrays with long, so that even if like it reaches 1e10, we are able to like not getting integer overflow. Okay, now what we'll do, we'll simply like iterate through all the subarrays, okay, and maintain this running sum. At each step we'll update this running sum, and once we increase, we'll also do like odd subarrays percent equals to mod. Okay, at each step we'll be modding this as well, so that it does not exceeds 1e9 plus 7 and it stays in the range of integer only. In the end, finally we'll be returning this count. As you can see, like this will be of the order of n square, hence it will give TLE here. So what can we do to further optimize this solution? So this this problem statement seems very familiar, right? Because we have like multiple problems where we need to find, suppose, number of subarrays with a given sum, number of subarrays with a given XOR value. So we have like these are pretty standard problems, and what do we do to solve these kind of problems? We have like solved multiple problems similar to this concept on our channel as well. So we usually use like prefix, sum plus hash map, right? Whenever we want to like count, return the total number of subarrays which satisfies the condition of like having some sum or having a particular XOR value or something related to that, then we generally try to tend towards like using this prefix sum plus hash map technique. So now how we'll be using this technique here is we'll maintain the prefix sum that we have till now. So suppose we are at index I in the array, and the current prefix sum that we have is prefix sum we have. Suppose prefix sum prefix sum is sum of values from arrow 0 plus arrow 1 till arrow of I. Okay, so this is the prefix sum that we have. Now what can be the conditions at given index I? At given index I, it may be possible that this prefix sum is odd. Okay, so if this prefix sum is odd, then that means what do we need? We need if, so suppose the condition was we need to make the sum as odd, right? So if we need to make the sum as odd, what can be the conditions? So if our prefix sum till I is odd, then we simply need to find out, means will be return, means finding out if we delete this portion with even subarrays. Okay, so then also this will portion will remain even odd only. If you suppose again remove some portion with even sum, then again this portion remaining will have odd sum only, right? So what do we need to do in this case? We simply need to find number of number of prefix sums which were even till now, right? So we can maintain a count of even prefix till now, and we can means simply update our result with the number of even prefixes that we have encountered so far, and the number of even prefixes that we have encountered so far would be added in our result, and that will be denoting the number of odd prefixes at this particular I. Okay, and similarly if our prefix sum is even, then that means the prefix sum till I was even. So if we remove any segment which had odd sum, so if we want to get a subarray which has odd sum, so we need to remove the prefix which had odd prefix, right? So if this is the odd prefix, so obviously odd plus odd will make even. So hence if we want to find out the number of subarrays ending at this I which has odd sum, we'll need to find out the number of positions, means find number of prefix sums which were odd, means odd prefix. So we just need to keep track of these two values of the number of prefixes which have had odd sum or number of prefixes which are even sum. Okay, if you maintain these two values, then based on the current prefix sum that we have, if it is odd, then we need to find out the number of evens that we have encountered so that the remaining sum remains odd only. So if we okay, and if we have the even prefix, means if prefix sum as even, we need to remove the odd portion so that the remaining portion is also odd, and that will account the number of subarrays ending at I. Okay, so this is what we'll be following, and this is a pretty standard approach to solve these kind of problems where we simply means either we use a hash map, and here the hash map only has two values. Okay, two values, prefix odd and prefix even. Since we do not need, means we can simply use these two variables instead of a hash map, and yeah, this will simply help us solve the problem here. So I hope means if you have solved similar problems before, this will be very straightforward to solve. And if you haven't, I will suggest you to solve problems like number of subarrays with given sum, okay, or with given XOR value, because sums and XOR will behave same in the prefix thing. If we want, suppose we have this prefix and if we remove the XOR part of this, so we'll take the XOR of both parts, so we'll get the XOR part of, means this part. Okay, so with given XOR value. So for these kind of problems, you should be able to utilize this prefix sum plus hash map technique, and you will be means this will help us a lot. And as you can see, it has helped us in this case as well. So let's see the code for this approach. So what do? We simply see this is the current sum, which is the prefix sum. Now we increase the current sum. Now if prefix is odd, means current prefix is odd. So we need even prefixes. So that means till 0 till I, this was odd. So we need to find out the number of prefixes ending at I which are odd. So we need to find out these odd values. So we'll simply find out the prefixes which had even value, so that this will help us. Means suppose till this part it was even, then again till this part it was even. So suppose it was even at two places. That means we'll simply find out, means we'll have two subarrays which will have odd value or some value, and which will be ending at I. So this is what we'll do. We'll update our count with even count, and we take the mod at each step. And now since the current sum is odd, so we update the odd count, means the odd prefix count with 1. And initially, since for the empty subarray, means initially the sum is 0, so we initialize the even count as 1 and odd count as 0. Okay, and the second case where the prefix sum is even, we simply find out the odd prefixes that we had. So it will simply be updated by count equals to count plus odd count, and we'll be increasing the even count because currently the prefix sum is even. So for further values, this even count is updated, and we finally return the count. This was like a pretty standard approach to solve these kind of problems, and as we can see, like the approach would be of the order of n and the space is constant here. So I hope like you now have an understanding of how we'll be utilizing prefix sums, because we have solved multiple problems based on the same concept. And yeah, this like will means help us a lot in solving a lot of problems. So that's why I picked it up today as well, so that like we can have a solid understanding of this. So let's try to submit the code here and see. So this is the same code that we followed of finding out prefix sum odd or prefix sum even, and yeah, it runs in 4ms or big of n, which is very fair. So I hope like you will not be able to understand like how we'll be utilizing this prefix sum plus hashing in similar problems, even if we had suppose we had modified it with suppose we had even sum. So for even sum, what we would have done, we need to find the prefix with even sum. So for I we need even. So suppose this was currently odd. So to find the even, what do we need to do? We need to remove sum, means to make the overall portion as odd. We need to remove some, since this entire portion is odd, so we need to remove some odd. Then only this portion will become even, right? So for odd, we'll be removing odd, and for if the prefix sum till I was even, then we'll be removing even part only. So this will means this can be modified with even sum only, or there can be multiple like problem statements possible. So this is how we'll be solving these kind of problems. And yeah, if you have any doubts remaining, feel free to comment down and I will be happy to respond. Thank you for watching.